Hello students, I welcome you all once again. I am Chetan Rajoria from ABES Engineering College, Ghaziabad. So in this lecture, which is basically the third lecture of our video lecture series, we are going to discuss in detail the concept of Varignon's theorem, its statement and its proof. So let's start directly. In the previous lecture, we were discussing the methods to find the resultant of various types of forces system. We discussed about the method to find the resultant of concurrent force system as well as non-concurrent force system. And I told you that in case of non-concurrent force system, we need a theorem to find exactly the location of the resultant, from where that resultant is passing, from the upper side or the downward side, from which side the resultant is passing. So what is that Varignon's theorem? So we will start from its statement. The statement of this theorem is that if there are two or more than two coplanar, yeah, it is important, coplanar non-concurrent force system then the sum of the moments of all these forces about a point is equal to the moment of the resultant of those forces about the same point. If there are two or more than two coplanar non-concurrent force system, then the summation of the moments of all the forces about the point, about any point, is equal to the moment of the resultant of those forces about the same point. So if suppose there are forces F1, F2, and F3, and the resultant of these three forces is R. Now we arbitrarily choose a point in that plane and said that point is O. Now we take the moment of these three forces F1, F2, F3 about that point O. And let us suppose these moments are M1, M2, and M3. One or more than one forces may be negative also. Negative means anti-clockwise and positive means clockwise moments. So algebraically, we add up these three moments M1, M2, M3. This summation will be equal to the moment of the resultant of these forces about the same point. So this is the theorem called Varignon's theorem. And for this, we will draw a diagram for proving this. Suppose this is our normal Cartesian coordinate system. This is y-axis and this one is x-axis. Now, let us suppose there are two forces we are considering here. This force is F1 and this force is F2. Okay, and the resultant of these two forces is R. So how to locate this R? We will use the parallelogram law. Draw a parallel line from here and another parallel line parallel to this force F1 from here. So this will be the resultant of these two forces. Just a minute, sorry. This will be the resultant. Now this resultant is R. Now how to prove this statement? For this, we will choose a point on the y-axis. Suppose this point is M. Okay, arbitrarily I have chosen this point M. We will take the moment of all these forces F1, F2 as well as the resultant R about this point M. Now for taking moment, what we need to do? We need a perpendicular distance from that force. Okay, from that point about which we are taking the moment. So if we will drop the perpendiculars. So let's drop the perpendiculars. The first one, 90 degrees. The second one, perpendicular to the resultant. And another one, perpendicular to the force F2. These angles are 90 degrees, all these angles. So we have dropped perpendiculars on these three forces, F1, F2, and on the resultant R. Now, suppose these points are, let's mark these points. Suppose this point is M, this point is N, and this point is P. Okay, and as usual, this point is the origin O. Okay, sorry, we have already chosen this point M, so we need to change this point. Suppose this point is N. Just a minute. We will take this point as K. Okay, sorry. Now, what we need to do, we will mark some angles also. Suppose this angle is theta1, this angle, this angle is theta2, this angle is theta1, and this angle is theta. Okay, the angle of these three forces from the x-axis are theta1, theta2, and theta, respectively. So, what will be the first moment? Means moment of the first force F1 about the point M. M1 will be equal to F1 multiplied by this perpendicular distance. F1 multiplied by perpendicular distance MK. And MK can be written in terms of this angle theta or this distance MO. How? Let us see. Look at this angle theta1. This angle is theta1. Therefore, what will be the value of this angle? This angle will be clearly 90 minus theta1. Now this is 90 minus theta1. This is 90. So therefore, this angle must be theta1. Right? Similarly, we can conclude that if this angle is theta2, the angle made by the force F2 will from x-axis is theta2. Therefore, this angle will also be equal to theta2. And last one, this angle will be equal to theta. Geometrically, we can prove it using some basic fundamentals of triangles. So, MK can be written as MO cos theta 1. MO cos theta 1, because we already proved it that this angle KMO angle is theta 1. So MK can be written as MO cos theta 1. Right? Similarly, what will be the value of the moment of the second force F2 about the point M? This moment will be equal to F2 multiplied by the perpendicular distance. So this perpendicular distance is MP. Now MP can be written in terms of MO once again. Consider this triangle MPO, in which MPO angle is 90 degree. So MP can be written as MO cos theta 2. Okay, so this is MO cos theta 2. Now, what is the value of the moment of the resultant? Moment of the resultant will be equal to R multiplied by Mn, because this is the perpendicular distance, okay, for taking the moment M into N, Mn. Now Mn can also be written in terms of Mo. can be written as MO cos theta, because this angle is theta. This one is theta. R MO cos theta. Let's mark this as 1, 2, and 3. Let's add up first and second. We get M1 plus M2. M1 plus M2 will be equal to F1 MO cos theta 1 plus F2 MO cos theta 2. MO common, it is F1 cos theta 1 plus F2 cos theta 2. Now, what is this part? F1 cos theta 1 plus F2 cos theta 2. If you observe it carefully, you will get it. It is the summation of the horizontal component of these two forces, okay, which we are studying here, F1 and F2. These are the two forces which we are analyzing here. This is the summation of the horizontal components of these two forces. And as per the principles of mechanics, the summation of horizontal components must be equal to the horizontal component of the resultant of these forces. So I can write M1 plus M2 is equal to MO multiplied by, this bracket can be replaced with R cos theta. Now, look at this. MO into R cos theta. What is this? MO into R cos theta. This is basically equal to MR. So I can write like this. M1 plus M2 is equal to M. This is what we are trying to prove here, that the summation of individual moments is equal to moment of the resultant of these forces. That was the statement of Varignon's theorem. So in this way, we have proved it, the same statement which we discussed a few minutes ago. It is very helpful theorem, especially for analyzing the non-concurrent force system, okay? With the help of which we can exactly locate the location of the resultant. So thank you so much for this lecture. In the next upcoming lectures, we will discuss some numerical problems, and we will take up all types of problems like concurrent as well as non-concurrent force system. Especially, we will start with a system of bodies in which there will be repeated applications of Lami's theorem. So thank you so much for joining this lecture. See you soon.